So let's look at 4.1. We'll do 4.1 notes today. They're pretty short. And then we'll do 4.2 tomorrow. Most of this you're not going to lesson 4, chapter 4, unit 4, whatever. You're going to notice that it's just an extension of what we've been doing in the last 2 units. So we won't do 4.3. You're just going to watch some videos on that. I would just leave it there for now, but eventually, yes, you're going to take it out. And then we won't do 4.5 because we've already done it. So you're going to watch some videos on that. Just to kind of refresh there. So, lesson 1, interpreting the derivative in context. That's basically what we're doing in all of Unit 4 is just taking the derivative and looking at it more in depth, doing some applications of it. So, in the last 2 units, we've defined the derivative graphically, algebraically, and numerically. We know it's the slope of a tangent line. It's also the instantaneous rate of change at a point, right? In this lesson, we're going to interpret the meaning of the derivative in a verbal, in context of the real world. So, looking at Leibniz notation one more time in a different way, he stated that the variable y depended on x. And if y equals f of x, the derivative could be expressed as the derivative of y with respect to x, right? dy over d of x. If we allow ourselves to think as d as a small difference in a process, we're reminded that the derivative is simply the ratio, the limit of the ratio in the familiar form. So the change in y over the change in x value. So we're talking about basically the slope, right? So we can read d over d of x as the derivative with respect to x of whatever function we're talking about. So here, the derivative with respect to x of y, or f of x. It can be a little cumbersome when you need to specify the exact x value where you need to evaluate the derivative. However, the benefit is that you can read so much about the rate of change through this expression. It's very easy to write f prime of 3. We know that's the derivative of f at 3. With Leibniz notation, we will write the derivative in the format that looks like this, yes? It means the same thing, correct? All right, looking at example 1, it says, let's take a look at this thing right here and talk about what does it mean. Well, the function name is y, right? The independent variable is x. And this is talking about finding the rate of change when x is 3, yes?
Yeah, x equals 3.
What did I say?
Is that what it means?
Yeah, find the rate of change when x equals 3. Sorry. Not sure if I said that right the first time. So, finding the rate of change when x is 3. That's basically what this whole thing means, right? So in example 1, it says, Sean is cleaning out his saltwater fish tank and needs to drain some of the water in order to adjust the saline levels. If the volume of the tank V is in gallons, is being drained over time t in minutes, what is the meaningful representation or interpretation of the following statement as it relates to Sean's fish tank? Well, our time is 3, right? 3 minutes. Yes?
Mm-hmm.
So at 3 minutes, what do we know?
The volume is
The rate of change of gallons. The rate of change of the volume in gallons is -2 gallons per minute.
Okay, so what does that mean in terms of the fish tank?
it's losing 2 gallons per minute. per 3 minutes. Wait,
At 3 minutes,
at 3 minutes.
the fish tank is being
Drained.
drained. Because it's negative, right? So you said -3, so yes, it's being drained.
At a rate of 2 gallons per minute.
At an instantaneous rate. Of 2 gallons per minute. So we knew this because v of t, or v prime of t, the derivative, right, is the slope of the tangent line. Yes?
Alfredo Juarez, if you're in the building, can you report to the food lab, please?
Oh,
Yeah. And the derivative at 3 equals -2. That's what this is telling us, yes? And it's negative, which means that water's being drained, yes? Okay. So this was a very good verbal expression of that. All right. Just like in any other language course, we need to use proper names, spellings, grammar, and grammar conventions. AP Calculus is no different than AP Language. There are many real-world functions that depend on variables other than X, Y, or time. Learning to read and write the correct notation will help you succeed on free response prompts throughout our course. So looking at A, it says the Alberta tar sands are one of the biggest oil reserves in the world. Yet extracting the fossil fuel costs more than the profits made. If the cost, C in dollars, is to be extracted, to extract a barrel of oil is losing $3 on every barrel, write a derivative. So first of all, we're talking about a function where the cost is our function, right, in terms of barrels. Do you agree with that? So the cost is the function in terms of barrels. And I'm going to say C equals cost in dollars, yes?
so would it be D of C over D of B? If we're writing it C equals F of B.
Yeah.
We're going to talk about the function in terms of barrels, so it would be
Oh, C is
The co-
replacing Y, never mind. So it would be D of C over something though, right?
D of C over D of B. Is that what you
Oh,
said?
yeah. Okay.
The cost in dollars, right? So you got to remember to define what you're using. So if it doesn't tell you in a free response, then you need to make sure that if you're using some sort of shorthand, then you define what shorthand you're using, right? So C is the cost in dollars, B is the number of barrels.
We have to define that.
Yeah, if it's not given to you and you choose to write something like this, because what is C? Well, it tells us C is dollars, so that part is probably okay. But it doesn't tell us anything else, right?
Right. Okay. Yeah.
Okay, so we're talking about the derivative of F in terms of B, and you said this was the derivative of C in terms of B, so DC over DB. And what did this equal?
-3.
-$3 per barrel, correct? Or in different notation, DC over DB at some time equals -3. Yes? We don't know what the time is, so I just put t down there. Where t equals t, essentially.
Wait, so. Okay. Okay, yeah, I see.
Looking at B, the Deepwater Horizon oil spill is regarded as one of the largest environmental disasters in American history. The oil leak was discovered on April 22nd, 2010. BP originally estimated that the flow rate was about 790 cubic meters per day at the end of the first week. So if we're talking about 790 cubic meters per day, we're talking about a volume. Do you agree with that? So I'm going to say the volume V in meters cubed. And what else do we need? We need a time, right? So what are you going to say time is? Weeks. You could say weeks. I'm going to specifically say time in days. But if you had said time in weeks, could you have done that? Sure. Your time would just be different than what my time is, right?
Right.
But you have to define what you're using. So if those are the two variables we're using, we're talking about the volume as a function of time. Do you agree with that?
Okay.
And so this was a rate when my time in days was what?
1.
I used in days, right? So this was the derivative at 7 days, right? Because the first week.
Okay.
Or dv over dt when t equals 7. Do you agree with that? And so f prime of 7 equal 790 meters cubed per day. Because I defined my time in days. If you defined your time in weeks, it would have been f prime of 1, right?
So which one is your answer?
All of that.
So you get to write them both ways?
So f prime of 7 is just showing you that's the derivative of the function at 7 days, right?
Okay, yeah.
And dv over dt is the derivative of the volume in terms of time, yes? So we're just trying to interpret what all of that means. So here, if we used v, it'd be dv over dt. It's a function of time, right?
Right. Okay.
So you're just kind of using all of this to think through the process, knowing that it may be given as this, and it means the same thing as this. Yes? Does that make sense to you?
Mm-hmm.
Okay. The population P of the endangered mountain gorilla has an ongoing study tracking the number of gorillas since 1992. The population increased by 114 gorillas during 2003 of the same study. So we're talking from 1992 to 2003. Yes? So you got to take that into consideration. What are we talking about? We're talking about P, which is population, right? And we have to have some time. Do you agree? And what is our time?
Years.
Yeah, time in years. And so you're talking about the population as a function of time. Do you agree with that? So the derivative of f when time was what? Well, from 2003 to 1992, we're talking about how many years? 11 years. So the derivative at 11 years, or the derivative of the population in terms of time, when time is 11 years. Do you agree with that?
Mm-hmm.
That's what this means. The derivative of 11, derivative of the function at 11, is the derivative of the population in terms of time when time is 11 years. And what did that equal? 114 gorillas per year. So in 2003, that was the rate of change, right? It increased by 114 gorillas. Okay? Suppose a planet is discovered in 2024 and its name Newtonia.
I'm confused
Yes.
on why we subtracted then, if we're
Just to find the number of years. So this is at 11 years, right? At 10 years, it could have been a different rate of change,
okay.
right?
11 years. Yep.
Because it was in 2003.
Okay, yeah.
Does that make sense?
Yep.
Okay. All right. Suppose a planet is discovered in 2024 and is named Newtonia. If the alien population P of T, so it gives us the function here, population in terms of time, is recorded in millions of aliens, and T is represented by the number of years since the planet's discovery, so the number of years since 2024, right? Because that's when it was discovered. Explain the meaning of each of the statements below. So here, P prime of 3 equals 0.5. So we're talking about the derivative of the population in terms of time, correct? Specifically when time is 3 years, and it tells us it is 0.5 or 1/2. Is that fair? So, we know we're talking about in 3 years. So, in T equals 3, which would be what? 2027? The population on Newtonia is it increasing, decreasing?
Increase.
Yep. So we'll be increasing by, now we're talking about in millions of aliens. So half of that would be
500,000.
by a rate of 500,000 aliens per year.
Wouldn't we technically be the aliens? Wouldn't we technically be the aliens if we went to their planet?
Probably so. Okay, so what does this mean? What's that -1 there? Derivative. No, not derivative.
Or the inverse.
Inverse. So the inverse of population, right? So now we're talking about 7.5 is the
Oh, the X is the millions.
and 5 is the
Year. Time.
yep.
Year.
That's right. Remember? So the population and we're no longer talking about a rate, are we? So the population on
So we can't write it like that?
what?
Like the one above, like DP of DT?
No, because you're not talking about a derivative,
Ah.
right?
So that's not a rate, not a derivative.
Well, think about it this way. Before our X was our population. No, our Y was our population because that was the function, right? And our T was our X. So thinking about it that way, then now our population would be across and our time would be up, right? That's what we're talking about here. So we're talking about the population growing in terms of time. Yeah. So the population on Newtonia will be, this tells us the population, doesn't it?
Yeah.
7.5 million? Because it's talking about millions of aliens. 7.5 million aliens.
5 years from its discovery.
5 years after 2024. Or in, what, 2029? That'd be 5 years. So that wasn't a rate. Now we're talking about a rate again, aren't we?
Yeah.
The rate of the inverse. Yes? So again, we're talking about when the population was 7.5 million aliens. Yes? it takes 0.75 of a year to do what?
Increasing. Or
Yeah. For the population to increase by what?
3/4.
The 3/4 is the year. It'd be a million. Right, a million aliens. 3/4 of a year for the population to increase by 1 million aliens. And specifically on Newtonia.
So can we write that as a derivative?
The inverse of the derivative, so
Oh, that would be complicated.
yeah, it would
But
be.
can we do the dp of dt is st is equal to 0.75? Is equal to 7.5?
No, because it's not equal to 0.75, is it? The rate is 1,
Oh,
right?
yeah. Okay, yeah, that's confusing.
Yeah.
Where are we getting that the rate is 1?
Because it's talking about in millions of aliens, right?
Mm-hmm.
So the rate's got to be in 1 million aliens. Here, the function is in terms of 1 million aliens, right? Or in millions of aliens. So the 0.75 or the 7.5 is the population. We determined that here, yes. And if it just had equals 5, that was when it was 5 years, right? But that's the derivative of this. So we're talking about a rate of increase of what? Of aliens. Yeah.
I get it, I just don't think I'd be able to get it by myself.
Yeah. Well, that's why we're doing it now, so that we can keep practicing that. The ones where we're doing the derivative of the inverse are harder to interpret. Okay. And the next example will show how clues from the units can help you recognize interpretations of the derivative as they relate to real-world situations. Suppose you launch a water balloon from a giant slingshot. Let S of t give you the distance in feet that the water balloon travels from its initial starting point as a function of time t in seconds. Explain the meaning of the derivative notation. So here, it gives it to you in different ways, right? The derivative of s in terms of time when time is 2 years is 38 feet per second. Yes? S prime of 2 is the same thing. It just doesn't, when you say s prime of 2, that doesn't give us the time necessarily, right? So that's why this is a better form when you're trying to interpret it. Does that make sense to you?
Does it give you the time?
Here, what is the time?
2.
2 years. So when time is 2 what?
Times 2 seconds, the rate of the balloon is traveling at a rate of, at an instantaneous rate of 38 feet.
Yeah.
Per second.
The water balloon is moving at an instantaneous rate. Oops. What is it? Instantaneous. What's the derivative of position?
Velocity.
Mm-hmm. So at instantaneous velocity of 38 feet. We talked about
Oh, the first derivative, the second derivative.
Mhm.
The second derivative is
acceleration.
acceleration.
Yep. So position, velocity, acceleration.
Makes a lot more sense when you're in physics.
Yes. Yes. Because you've already done it in physics, right?
We don't do the math part in physics, though.
Right. But now you're doing the math part of physics in calculus, essentially. Yes? S of t is your position. And that means that v of t is the derivative of position, which gives us velocity.
So are we gonna have to write that second part down, or are we just interpreting the?
That's this, you're just interpreting it, but this is how you get to that with the velocity specifically, right? So it's important to tie that together. Position, velocity, acceleration. And we're going to do more of that too. The total cost C in dollars of an airplane flight is a function of the number of passengers in can be calculated by derivative airlines using the function C equals f of n. What does it mean to say f prime of 182 equals 58? Well, here, the derivative of C is the derivative f prime of 182, which equals 58, right? Well, what's the derivative of C? It means what? When, what is this inside? N is the,
Number of passengers.
So means when 182 passengers are on a flight the cost per person is, for the flight, is $58. Right. That's not how much they charge, that's their cost, right? And then they jack up their prices. In example 6, non-potable water is being pumped into a processing center where the depth in feet of the water at time t hours is given by y equals h of t, so the height in terms of time. Interpret the following statements using the proper notation. So this would tell us the depth is
Depth is 5 feet.
5 feet.
after,
7 hours.
yeah. So the non-potable water is 5 feet deep. After 7 hours. Now this one's the derivative, right? So now we're talking about a rate, yes? And is it increasing or decreasing?
Increasing.
So the depth of the water is increasing at a rate of 0.6 feet per hour, specifically at time t equals 7 hours. Does that make sense to you? Inverse. So now this is an inverse function, right?
So at 9 hours.
After 9 hours, yep. The non-potable water at the processing center always want to tie it back to what we're talking about, is what?
7
Mm-hmm.
feet.
Yep. Keep forgetting the knee there. All right. Now we're talking about the derivative of the inverse. So, this is still the depth of the water, do you agree?
Yeah.
So when the depth of the water is 7 feet, this has got to be a rate, yes? When the depth of the water is 7 feet, it takes what? 1.4 hours for the depth to increase. What are we talking about? 1 more foot. Yes?
Yeah.
Does that help a little bit with the inverse? A little bit?
Tiny.
Okay. So that's it. That's all we're doing. Not a lot of calculating, right? Just interpreting. Yes? You can see here your assignment. Not too long, right? So you're gonna get used to the inverse there. Correct? Got 3 inverses there. Try and figure them out before you look at the key. Yes?